Okay, so we have a question, and the question is, what is the capacity of a can that has a height that is 15% more than the original can? And we know that the original can has a volume of 220 milliliters and a diameter of 5 centimeters. So we're going to write down some stuff that we know, and we're going to write down or talk about some assumptions first. So the first thing that we know is that we're looking for, our shape is going to be a cylinder, and I can't spell cylinder, so that's why it's not popping up. There we go. Let's pop one of those in there. Good. Then we know some stuff about our cylinder here. It has the diameter of 5 centimeters. Remember, diameter doesn't really get us anywhere, so let's put the radius down right away of 2.5 centimeters. That's a little decimal there. Okay, we also know that the volume of the original can is 220 milliliters. And right away, 220 milliliters. Right away, I see that I have centimeters and milliliters, and I need to have them be the same unit. So I'm going to look at my conversion sheet, and when I do, I see that it says 1 milliliter equals 1 centimeter cubed, which is a great, easy conversion. So I'm going to convert this, so the volume is actually 220 centimeters cubed. So I know a volume, and I know the radius, but I need to figure out a height and then make it 15% more and then find a volume. So this is our to-do list. To do, we need to find 1, the height, 2, 15% of the height, that's percent, and we need to find the new volume. The new volume is from that word that says capacity. So it asks us what the capacity was. Capacity is volume. So if we find the height of the original can, and then we increase it by 15%, then we'll use that new height to find the new volume. So I'm just going to add a page on here, I think. And yep, here's the new page. Should still be rolling. So for the new page, we've got, we need to find height. We have our formula for a cylinder. Volume equals pi r squared times h. Now, these are some of the assumptions we have to make. We have to assume that the can is flat in the bottom, and assume that the can is flat on the top, and assume that they fill the can all the way up to the top. In real life, they don't actually do that. In real life, the cans have little dents in the bottom, and then they usually taper in a tiny bit at the top, and they don't usually fill to the top. So those are our 3 assumptions. Now I want to find H, so I need to get rid of the stuff that is not H from that side, and I'm just going to do the opposite of what it says to do. So right now it's telling me that I want to do multiply pi r squared, so I'm going to divide both sides by pi r squared to make them go away. If I divide both sides by pi r squared, then what I'm going to end up with is I'm going to end up with V over pi r squared equals this whole piece cancels out, it goes away, so it equals H. And then when we try to do our formulas so they make sense, we always put on the left what we're looking for, and on the right is the stuff that we know and we're going to use. So that being said, I'm going to plug in my volume of 220 centimeters cubed, and I'm going to put in pi and the radius squared of 2.5 squared. I'm going to pick up my calculator. So 220 divided by pi divided by 2.5 divided by 2.5 gives me 11.21 ... And we're not going to use any more than that. We'll use our 4 digits there. So this is that's our height of our shape. So that we found our first thing on our list. The first thing on their list was the height. So now we're going to go to the next thing on our list, which was to find 15% more. So I'm going to add another page. So we've got the height of the can is 11.21. We want centimeters. We want to find 15% more, a 15% increase. 15% increase means we're going to have the entire 100%, plus we're going to add 15% to it. So that's going to give us 115%. And we know from doing this before that that's the same thing as 1.15. So for the new height, I'm going to take, I'm going to do 115% of 1.21 or 1.15 times the 11.21 centimeters. And when I do that, I end up getting the new height, sorry, I dropped the H off of there, of 12.89 centimeters. So this is our new height. Good, so we have a new height. So if we have a new height, then we have to figure out our last part of this. And the last part is to figure out the new volume. So we're gonna do one last thing. So the new height is 12.89. We're still using our same assumptions of our can that's flat on the bottom and flat on the top and filled to the top. So I'm just going to use my volume formula and plug in what I know. So the volume formula is pi r squared times h. So volume is pi times 2.5 squared times 12.89. And if I do that, just get the calculator here, 12.89 times 3.14 times, because there's all multiplication, it doesn't matter the order that you do it in, but you multiply them all together, and I get the volume equals 252.96, that's a point, sorry, 625, it goes on and on and on, centimeters cubed. We don't want to, we got to change two things in our final answer. So now we've got some numbers we need to then put them back into the same form that they were given to us. So before, when we got the numbers, we were given 220 milliliters. It was whole numbers. So we're going to round this to whole numbers. So we're going to round that. So either keep it or move it up. And we're also going to put it in the correct unit. So first we'll do the rounding. And the rounding is going to give us 253 centimeters cubed. Because it's a liquid in the can, we want to put it back into the milliliters. And it's the 1-to-1. So our final answer is the, in words, capacity of the new can is 253 milliliters. And that hopefully gets you a better understanding of how to do these problems. Good luck.